Welcome back. We have another example. Still triangle ABC. Yes, we can change the letters. We just didn't keep life easy. In this case, in your notes, you're only given the two side lengths, A and B, and the measure of angle A. I've already gone and drawn the diagram, so we have something to visualize. So the measure of angle A is 35 degrees. Its side across from it has a length of 6, and then side B across from angle B has a length of 8. All right, so we are going to solve the first triangle. And again, we have to solve for angle B first. So sine of B over 8 is sine of angle A, or 35 over 6. Cross multiply to isolate sine of B. And then in your calculator, you're going to do sine inverse of the ratio 8 sine of 35 over 6. Once you type that in your calculator, you'll get a value of 49.9 degrees for the measure of angle B. Cool. All right. To get the measure of angle C, piece of cake. Subtract everything from 180. 180 minus the given 35 for A and the 49.9 for the measure of angle B gives us a value of 95.1 degrees for the measure of angle C. Okay, and our last piece to solve this entire triangle is to solve for side C. Well, now that we have its angle measure and we have a given set of information for angle A and side A, we can set up a ratio of C over sine of 95.1 equals 6 over sine of 35. Cross multiply to isolate C. And then we solved, and 6 sine of 95.1 divided by sine of 35 gives us 10.4. So our side lengths, 6 for A, 8 for B, and 10.4 for C. And I want to make sure it's not exactly 10, because a 6, 8, 10 triangle is a 3, 4, 5 Pythagorean triple for right triangles. So I definitely want to show that it's a little bit more than 10 units long for that longest side. All right, we do have the side-side angle relationship. We need to check for a second triangle. We have already solved for that first angle. The measure of angle B is right under 50 degrees, 49.9. First off, we've got to determine its supplement. Its supplement is 180 minus 49.9 degrees, which is 130.1 degrees. Okay, great. Now we need to check, is the second triangle possible? So remember, we're going back to the given, 35 degrees for angle A, the supplement of our B, which is 130.1, and we want to see, is angle A plus the new B less than 180 degrees? It sure is. 35 and 130.1 gives us 165.1 degrees. Okay, great. Now we need to solve for our new angle C. Okay, so we'll take 180 minus that 165.1 and we get 14.9 degrees. So in our new triangle, A is 35 degrees, angle B is 130.1, and angle C is 14.9. So now side B really should be the longest. So if 8 is the longest and angle A is 6, then in angle C with side C, it should be really short. So let's see what happens. C over sine of 14.9 degrees equals 6 over sine of 35. Cross multiply to isolate C, and then type this ratio, 6 sine of 14.9 divided by sine of 35. Type that into your calculator, and we determine that the length of side C is now 2.7 units long. Teeny tiny, because it is the smallest angle. It's under 15 degrees. All right, good job. We got a couple more to practice. All right, in our next angle, we have triangle ABC. I put one up there for you. You can label as needed. The measure of angle A is 60 degrees. Side A is 9, and side C has a length of 10. Okay, so the first thing that we have to solve for is angle C, because we have its side length and we have the pair of side A and angle A. So sine of C over 10 is sine of 60 over 9. Cross multiply and isolate sine of C. And then we're going to take the inverse. So angle C is sine inverse of 10 sine of 60 all divided by 9. And your calculator, that will round to 74.2 degrees. Perfect. This is the largest angle so far, And let's check to see what the measure of angle B is. That's the last one we're missing. 180 minus angle A is 60 minus angle C, which is 74.2, gives us a value of 45.8 degrees for the measure of angle B. All right, so now we know angle C is the largest, side C is the longest. Angle A is in the middle with 60 degrees, and the length of side A is 9, a little bit less than 10. So that tells us that if angle B is the smallest angle, its side length should be the shortest. It should definitely be less than 9 units. All right, let's check. So B over sine of 45.8 equals 9 over sine of 60. Again, always go back to that given pair that we had, A and angle A. Cross multiply to isolate B. So in your calculator, you're going to type 9 multiplied by sine of 45.8 divided by sine of 60, and rounded to the tenths place gives us 7.5 units. So side C is the longest, and definitely side B is the shortest at 7.5. Now, do we have to check for the second triangle? We sure do, because we have a side, and an angle. So go back to the original angle you found, C, and its measure is 74.2 degrees. Its supplement, so 180 minus the 74.2 gives us 105.8. So right around 106 degrees. Okay, if it works, that's the measure of our new angle C. So we're going to look at the original A, that's given, 60 degrees, plus our new angle C, the supplement, 105.8. Is that less? Is there some less than 180? Definitely. 165.8 is definitely less than 180. That means we can now solve for a second triangle, first getting the measure of angle A. Oopsie, that's a typo. Oh, I'm sorry, it's a typo up here. It's supposed to be the measure. That was not a typo. Goodness, I tricked myself. Here we go. The new B, wrong angle. Sorry, guys. The original B was 45.8. The new B is going to be 180 minus the given angle A minus the supplement of C, 105.8, gives us 14.2. Excuse me, all my little misgivings there. All right, so the new angle C is 105.8. The new angle B is 14.2 degrees, and we can, in fact, actually solve for side B now. So B over sine of 14.2 equals 9 over sine of 60. Again, always go back to those given values. Keep your stuff precise as possible. Cross multiply, and in your calculator type in the ratio 9 sine of 14.2 divided by sine of 60 to determine the length of side B of our second triangle is 2.5. Cool. It happens to still be the smallest angle measure. A and C switch places this time. All right, let's see what else we got. Example 6, another ABC triangle. The side length A is 3, side length of B is 2, so that's shorter, and the measure of angle A is 40 degrees. Well, if I know that side B is shorter than side A, then its angle measure, angle B, should definitely be less than 40. Let's check and see if that's true. Set up those ratios. Sine of B over 2 equals sine of 40 over 3. Cross multiply and isolate sine of B. In your calculator, you're going to take sine inverse of 2, sine of 40 degrees divided by 3. Take a moment, type that in, see what you get. Hopefully you get that the measure of angle B is 25.4 degrees. Definitely less than the 40. Cool, so we're on the right track. Now to find the measure of angle C, we're going to subtract each of those angles from 180. So 180 minus 40, angle A, and 25.4, angle B, gives us 114.6 degrees for the measure of angle C. Cool. So that's an obtuse angle. That's definitely the largest angle, so it's across from the longest side. Again, not drawn to scale. Just stick with me. It's okay. All right, so side C over sine of its angle equals side A over sine of its angle. Again, going back to my givens. Cross multiply and isolate C. C is going to equal 3 multiplied by sine of 114.6 divided by sine of 40. And then since you're solving for a side, you type that in the calculator, and we approximate that C is about 4.24 units. So not much bigger than angle side A or side B, but definitely larger. So it does fit our pattern. Longest side length across from the largest angle. Smallest side length across from the smallest angle. Cool. Again, we do have the side-side angle relationship. We've got to check for that second triangle. Remember, we solved for angle B first. So let's find its supplement. What is 180 minus 25.4 degrees? 154.6. Okay, so with our given angle, angle A, and our new angle B, can we create another triangle? So 40 plus 154.6, is that sum less than 180 degrees? Definitely not. Not at all. There is no second triangle possible. That means in this example, we only have one unique triangle, only one that we can solve for. It happens. All right, there are two more examples. So take a quick screenshot for example 7 and examples 8. Jot down the answers. So example 7 does have two different triangles. I want you guys to try these on your own and check your work with the answer keys that are online. Okay, and then here's 8. In this case, we have one unique triangle, and that's because when we check for the second one, we go over 180 degrees when we're looking for that third angle measure. It does not work. Okay, so try those on your own, check them. Again, all of the answer keys are online with all of the steps shown like I've been showing through the previous examples. And if you guys have any questions, please make sure you reach out, let me know, and I'll see you later.